My name is Carla Smiterly. I'm the Director of Sales and Marketing for Allberry. In this presentation, I'll be discussing our passive oil containment system using oil reactive membranes, formerly known as SorbWeb, now rebranded to SorbNSeal. And in the presentation, I'll talk a little bit about our company and who we are. And then we'll get into details about the actual containment and answer any questions that you guys might have along the way. It's a fairly small group, so we're able to take questions if there are any along the way. So just a little bit about Allberry. So we are a Canadian manufacturer located in Barrie, Ontario. So we have 3 plants here. We've been in business for over 40 years. So what we do here is needle punch non-woven manufacturing. We don't get into any kind of usually commodity style products or we don't get into woven fabrics and that kind of thing. Our focus tends to be more on needle punch non-woven geotextiles and other types that are meant for high temperature, unique environmental applications, okay? We are blessed to have a team here of people who are experts when it comes to our fabrics and fiber and experts in the area where we serve our customers. So there are 4 segments to our business. One of them is secondary oil containment, which I'll talk to you guys about today. And we've been involved in containment systems since about 1992. Originally started with landfill type applications with geosynthetic clay liners, and now this is kind of our specialty with substation or secondary containment around substation transformers and above ground storage tanks. 50% of our business is industrial air filtration. So we make a lot of custom-made filter bags for bag houses or dust collectors for a variety of different industries. We tend to focus on industry-heavy areas. So that would be mining, asphalt, anything that has high temperatures and very fine dust. We also have a product line for material handling and conveyance. For that market, we are selling to the aluminum extrusion industry, and we have about 85% of the market share in that space. So there we are creating products to replace the traditional graphite materials that are used in that industry, which are highly toxic and carcinogenic. So our products are a very good alternative in that space. And then, of course, we also sell a lot of our fabrics by the roll for a variety of different applications. So sometimes for geotextiles for construction, we make those here, and we tend to usually get, make heavyweight geotextiles. And then we also make fabrics for whether it's acoustical purposes, like as in putting in speakers and things like that, or for other textile or other companies to turn into final goods. When it comes to expertise here, we have, as I mentioned, a lot of technical expertise when it comes to fabric and fiber. On the secondary containment side of it, we have Ode, who's our Director of Engineering here. He leads our civil group, which works as an extension of our customer's design team to come up with a secondary containment that's suitable for their specific site and sort of unique situations that might be going on in that site. A lot of the people that are working with Allberry have been here for a long time, so there's a lot of intrinsic knowledge when it comes to fabric and fiber. We also sometimes do partner with different companies to bring products to market, and we have an R&D division here that does a lot of development work when it comes to creating products for ourselves, but also partnering with our customers to see if we can solve environmental issues using fabrics and try to help them solve their issues that way. So today I'm going to talk to you guys about our smart fabric technology. Just to be clear, this is not a fabric that contains any kind of electrical devices or internet or anything like that. We call it a smart fabric because it is able to separate oil and water without using people or power. So we're solely relying on chemistry to do this. And there are two fabrics that we employ in our design that we're going to talk to you guys about today. So one is an oil blocking fabric and the other one is an oil absorbent. So the oil blocking fabric we refer to as our oil mat, and the oil absorbing fabric or super absorbent membrane is our SAM mat. Okay. So these materials look like basically a roll of carpet. So they're manufactured in the exact same way. They look very similar. One's black, one is white. So the oil blocking fabric is black. The super absorbent membrane is white. The difference between the two is the type of polymer that we put in it, okay, which gives it the different properties. So both of these rolls or both of these materials are manufactured and look like almost like a roll of carpet, if you will. They're about 1/4 of an inch thick. The rolls come off the line about 15 feet wide and 105 feet long. And the reactive chemical load or polymer loading is about 2.7 kilograms per square meter or 5 pounds per square yard. So it gives it the appearance of a roll of carpet. So if you've ever gone to a store where they sell, massive carpeting rolls, that's exactly what this looks like, okay? So about 1/4 of an inch thick. You can cut it to whatever width or length you need using simply a box cutter type of tool, okay? Now, the oil blocking fabric, as I mentioned, is designed to, it's basically a polypropylene geotextile that is needle punched with a polymer in between. The top and bottom fibers basically are designed to allow rainwater and snow melt to pass through this material. And then once the polymer comes in contact with the oil, it kind of turns that oil into a very thick grease, which forms kind of a barrier on top of the fabric and prevents the oil from moving any further than the top of the fabric. So it doesn't go to the underside. Okay, so this is a very good example here. In this video, you can see here, imagine that you have a containment system where this fabric is installed on the floor area of the containment or even as a perimeter. But in our case, it would be on the floor area of the containment. Rainwater and snow melt will pass through all the different layers of the containment system and naturally infiltrate into the soil below. If you have a leak or catastrophic failure, that oil is basically going to come eventually in contact with the mat on the floor. And in this case, it's on the vertical wall here. So any area of that oil, which is this blue liquid floating on water here, that is in contact with the mat is sealing the mat and basically preventing that oil from going beyond that point. And once that happens, basically the material starts to seal. Once it's totally sealed, it will contain all of that oil plus anything that comes afterwards, okay? So let's imagine, for instance, that you have a containment system using this material installed. Say that there is an event where it's raining and you also have a catastrophic equipment failure at the same time. Both things are going to fill into the containment. You're going to have a mixture of oil and water. The higher concentration of oil is going to rise to the top of the water. The water is going to continue evacuating the containment system through the floor. Small trace amounts of oil will be sort of removed and captured within the mat itself so that liquid passing through that floor and coming out on the other side is clean and meets the minimum discharge requirements set out in North America. But then once that high concentration of oil kind of hits the mat, it starts to gel and seal that mat and basically contain that high concentration of oil. And then you obviously, if you've had a catastrophic failure, you have this oil pooled in the containment, you do have to take steps to go and remediate that containment. If you leave it, yes, the oil will still stay there, but then it will start collecting everything else. So if it starts to rain again, all the water will, start pooling in it as well, just like I'm showing you in this video here, okay? But it does give you the ability to, contain that passively without any instrumentation or people having to do anything. And then, of course, you have a period of time that you do need to do your remediation and clean up afterwards. The superabsorbent membrane is an oil absorbent. So basically, this material is manufactured in a very similar fashion, except we're using white fibers, white polypropylene fibers, to needle punch the polymer in between. So construction is the same, polymer loading is the same, but the type of polymer that you put in there is different. This polymer has the ability to turn a liquid into a solid. So basically, if I were to take this polymer out of this fabric and just apply it to a liquid spill, for example, on the floor, it's going to turn that liquid into a solid, and it looks almost like a grain of rice, basically. And you can then pick it up and sweep it into a pan and dispose of it accordingly. In this, in our fabric, it has the ability of absorbing approximately 15 to 20 liters of oil per square meter, okay? And we incorporate it in our designs to act as sort of a way to mitigate any potential chronic leaks that can happen in a transformer without affecting the primary membrane. So you can see here that this material almost looks kind of like a rice type thing. So what it's doing is basically absorbing that liquid. Now, one of the big differences between this fabric and the previous one is that even if it's fully saturated like this, water can still flow through it. It doesn't do any, like it doesn't stop water from flowing. But again, it reaches a certain capacity, and once it does that, it can't absorb anymore. So think of it as like a sponge. If you put a sponge in a bucket of water, it's going to absorb as much water as it can, and once it reaches sort of an equilibrium, it can't absorb anymore. So same idea here. Once this mat absorbs as much as it can, that's it. It won't be able to absorb it anymore. The difference between a sponge and this fabric is if you pick up the sponge and you squeeze it, you can get the water out of it. Here, once that polymer is turned from this powder into sort of this solidified rubberized material, if you squeeze it, you won't be able to get the oil out, right? So it's not reversible. You can't change it back, okay? So this becomes very useful when we're designing a containment system. As you can see here, the entire floor area of the containment system is this mat that basically separates oil and water. And so it's permeable to water. So the area around the perimeter of the containment, as well as all of the concrete structures, is an impermeable liner. That is funneling all the liquid towards the floor of the containment, which is this mat that is able to separate oil and water. So the design basically gives you a type of containment that doesn't require any oil water separators, any kind of pump and treat systems. You don't need concrete at all. Or if at the very least you just use it for your pads and so on. It significantly reduces your installation costs because now all of a sudden, usually the average install time for something like this is between 3 to 4 days. Some of the larger containments might take 5 days, excluding the excavation, but it goes very, very fast compared to, say, building a traditional concrete containment, which could take a long time, anywhere from 3 to 4 weeks up to a few months, depending on how big it is. There's no real cracks or anything that you really have to maintain over time, other than ensuring that the materials are covered. And if there's any ongoing chronic leaks in the equipment, obviously you want to fix that so that you can extend the life of the containment. It's designed for differential movement, very similar to concrete. It also still offers you fire quenching ability because we're going to fill the containment with a fire quenching stone, which prevents and limits the spread of fire. Designed again for the life of the equipment. So all of these materials are polypropylene, and so in theory, plastic. Their theoretical life is in the hundreds of years. We're not expecting any of this to decompose or degrade over time. And so we're very comfortable to say that this will last the lifetime of the equipment, about 50 years, okay? It significantly reduces your risk associated with a spill because you're not relying on any mechanical devices, people, power to operate. The fabric or the containment is ready to react to an oil spill passively at any time, 24/7, okay? And again, as I mentioned, in terms of installation, it's very, very quick. The other thing that's very good or, favorable to this system, especially retrofitting existing substations where there might be things buried that you didn't know were there or not on any drawing, you can make changes to this as it's being constructed on the fly. So if a new foundation is discovered or needs to be added, you can basically use a box cutter to make changes. We can flexibly make those changes on the fly and adjust the containment so that the project keeps moving and it doesn't delay anything. If you later on need to expand the containment for whatever reason, again, very easy to modify, expand, long term. So we have many, many different designs for our containment systems, depending on site-specific situations and volume, type of oil, et cetera, et cetera. Today, I'm just going to focus on the most common one, and we're only really addressing here mineral oil-filled transformers, okay? So SorbNSeal, or formerly SorbWeb, is the design concept is basically an earthen berm style containment that's designed to be completely below grade and be maintenance free. The floor area of the containment is that oil blocking fabric I showed you in the first video, and that's the green line you see here. Over top of that, we're going to have our super absorbent membrane, which will manage any chronic leaks that could happen over the lifetime of the containment. That's the that's the red hatching here. And it's the second video that I showed you with the white fabric, okay? There's a few other layers in here, but I'll get into that a little later. But basically, you have an earthen berm, which is usually built or excavated on native soil. And then that is lined with the impermeable liners as well as all the vertical structures. So that'd be the piles in this case. So that's the pink material or liner you see here. So this is impermeable. And then we put a geogrid over the berm because the berm is kind of like the weakest point in the containment. So this depends on the soil bearing capacity and so on and so forth. So that geogrid just provides additional protection over the berm to prevent the berm from buckling. So it's the same material used in road construction. And then we build the containment again below grade and fill it with stone. So this gives you a containment system that is designed to be maintenance free and allow you to have full access to the equipment in a substation without having to climb over things or stuff like that, right? So it doesn't create any barriers for access. Now, when we work with you to design a containment system, as I mentioned, we're working as an extension of your team. Traditionally, we follow the IEEE guidelines for secondary containment, which call for 110% of the volume of oil, plus a 1 in 25-year rainfall event. Now, every client, when it comes to this, is very different. So you may have your own standards that you want to follow. You just need to tell us what they are, and we will follow those standards. We have a variety of customers going from 110% of the oil volume plus not any rainfall to be contained, or to be able to drain a specific amount of rainfall within a 4-hour period, or they want to incorporate a 1 in 50 or a 1 in 100-year rainfall, or sometimes they only want to contain 30% of the volume. Again, these are all very flexible parameters. You just need to tell us which standard you want to follow, and then we make you the best. We give you the best recommendation, but ultimately it's your decision. Okay. We follow best engineering practices, so we look at all the different things that in the site. So usually we ask you for things like a geotechnical report so we can understand what the soil conditions are, a site layout, transformer information, a grading plan if you have one, and the oil type. So again, this is very important. So we're using chemistry with the polymer. We need to make sure that the polymer that we have in the fabric is compatible with the oil that's in the transformer. We have tested a multitude of mineral oils, so we're quite confident we can address most of the mineral oils that are in the market. Now, every once in a while, we may come across one or two we haven't seen before. And if that happens, we send you a little test kit that you can do yourself, and it's a 60-second test. It doesn't cost anything, and we give you the instructions on how to do it. It's kind of like a little home science project. It's very, very easy to do. But other than that, for the most part, we've encountered pretty much any type of mineral oil that is out there in the market. Again, if the oil is not mineral and it's, for instance, you're using a synthetic ester, or you're using a natural ester oil, or something like that, design is going to look somewhat similar, but the layers may be a little different, and the polymer would definitely be different because, again, we need to match up the chemistry in the polymer, which has a specific chemical chain, with the chemistry in the oil, which again has a different chemical chain. So in mineral oils, which are hydrocarbon based, the chemical chain is different than in natural ester oil, for instance, which are naturally not derived from hydrocarbons, and so that chemical chain is different. We need to make sure those two things are compatible. And so again, we follow kind of your specifications if you have them developed for your unique project. So as I mentioned earlier, there are a few layers within our containment system, and I'll explain the purpose of that here. So at the bottom of the containment, you're always going to have a 2-inch layer of sand. This is going to act as kind of a cushion. So if there's any sharp edges or anything, they're not in direct contact with the mat itself. And then in that 2-inch layer of sand, you may or may not have this wick drain that I'm showing you here. So this wick drain is a low profile, 1-inch high, 6-inch wide subdrain, kind of like a weeping tile, wrapped with a geotextile. And the purpose of that drain is to collect water passing through the layers of the system and direct it somewhere else. So you only need that drain if the soil is not naturally permeable. So for example, if the containment system or the substation is sitting on sandy soil, we don't need that drain because the water is going to naturally infiltrate and go into the soil below. But if, for example, the substation is sitting on an area where it's all clay, it doesn't really matter how much water the fabric can pass through, because once it hits the clay, it's not going to go anywhere and it's going to back up into the containment. So in those cases, we need a subdrain to collect that water passing through the system to direct it to a ditch or city sewer, stormwater management pond, you name it. Oil is never expected to be in that subdrain. It's expected to be clean water that meets the minimum discharge requirements set out in North America. Okay, so that is one of the reasons why we ask you if you have a geotechnical report and to share that with us. Okay, if you don't have one, there are, you can do perk tests and things like that to determine the soil infiltration at the time of installation. So once we sort that out, we're going to build the containment. So at the bottom of the containment, we're going to have our oil mat or oil blocking fabric. That's the one I showed you in the first video that will congeal and seal once you have an oil leak or spill. The super absorbent membrane, that's the white fabric I showed you in the second video. It's referred to as the SAM layer, and that is installed over the mat, and that will act as sort of a sacrificial layer or protective layer to manage any chronic leaks that could happen over time in that containment system from any leaky equipment. That layer can be removed or replaced if required. So those are your primary filtration fabrics, okay? Now, we need to make sure that we have a way that those two fabrics don't get clogged or blinded by silt over time. If you've ever seen, those silt fences that are out there, and that's a non-woven that you have there. And if you've got water mixed with silt and dust, that basically, that fabric filters that out and sort of starts to blind the fabric and lose its effectiveness over time. We don't want that happening here. We want to make sure that these containments and these materials are working for the lifetime of that containment pit. So what we're going to do is build a pre-filter. And that's exactly what we do here with a 2-inch layer of sand, non-woven and woven. We're basically building a pre-filter within the containment system to prevent that silt or any dust accumulation over time from clogging those two primary membranes on the floor. And that is a very effective pre-filter. We're using natural materials to do that. And again, non-woven and woven for those purposes, and also for slowing down liquid. So the other factor we need to consider is if the transformer has a catastrophic failure, the oil coming out of that transformer is going to be very hot. It could even be on fire. So we want to make sure that once it goes through those stones, it meets some resistance and it slows down that flow. And what that does is allows the oil to cool down several degrees as it passes through this layer of sand, woven and non-woven, so that when it gets down to those reactive fabrics is at a much lower temperature, and they can effectively work. Okay. So this amounts to about 5 inches in thickness for the actual system itself. Once we have this laid out, then we're going to fill the containment with the fire quenching stone, which is really just a fancy name for a clean washed stone between 1.5 to 3 inches in size, easily available anywhere in North America. Okay, so clean washed stone, 1.5 to 3 inches in size. The actual containment capacity is going to be calculated in the fire quenching stone. So the materials themselves don't have any real significant ability to contain all of the oil you have in the equipment. Yes, they do absorb some and so on and so forth, but it's not of great significance. So the actual containment capacity will be calculated in that fire quenching stone. That will determine how big, in terms of footprint and depth, the containment needs to be. Now, usually when we make this calculation, we use a 40% porosity for the stone, or the spacing between the stones, in order to determine how big the containment needs to be. So some utilities might use 35%. So what that does is it basically increases the footprint of your containment. We have not had any problems finding stone anywhere in North America that meets the 40% porosity. So this is what we usually design our containments based on. So the actual depth of the containment is going, and the footprint is going to depend on how much oil and water you want to contain. Now, our containment systems, the minimum depth is 0.45 or 18 inches, up to 48 inches or 1.2 meters. That's the depth, that the range that we have. Minimum 0.45, maximum 1.2, okay, or 18 inches and 48 inches. That surface stone that you see here, we don't usually specify that. So utilities might have their own specification for surface stone. A lot of our customers use their surface stone and fire quenching stone as one and the same, so they don't have to source two types of aggregates. So the only thing with that surface stone is that we ask is you don't want to put anything that is like finely crushed, that has a lot of fines in it, because they're going to fall into the fire quenching stone and affect the capacity of the containment. And then the other effect is if you use crushed stone or very fine stones and you're in areas where it's subjective to very cold temperatures and ice buildup, you can actually create an ice sheet over top of that. And then if you had a spill, it might bypass the containment. So want to make sure that surface stone is a clean washed stone, and not a sort of a crushed stone, and it has kind of well graded over the range. So it's, again, close to 1.5 to 3 inches in size, or, if you got to be smaller than that, pretty close to that size. Okay. Now this makes the containment very, very flexible, because basically you can build this completely below grade. You can build it above grade totally or partially above grade. We can have the earthen berms as I showed you in the design here, or if you want, you can have a concrete wall, or you can have composite fiberglass walls. So the perimeter is really kind of up to your imagination. Now, this is very popular design for all kinds of substations. So in retrofit applications where you're trying to add containment afterwards so that the substation can meet today's environmental standards. In new installations, obviously for larger equipment, it's more cost effective than, say, a traditional concrete containment. For smaller equipment, still is a pretty good option. Now the savings range between large and small equipment might be a little smaller when you compare it with concrete. But if you look at the life cycle value of this system compared to, say, a traditional concrete pit, you'll find that this is in the long run, a much better value than the other one. So again, very little maintenance other than just a couple times a year, making sure that the fabrics are covered, and making sure that if there is a chronic leak going on with a transformer, that that's kind of resolved. There's not really much else in terms of maintenance on this containment. Okay. So this video here is going to kind of bring together everything that I just mentioned. So again, if you can't hear anything, just let me know and I'll just talk through it.
Here is a typical earthen berm containment pit, excavated to a specific depth, which is based on design requirements that can differ from project to project. Once the containment is excavated, the base layer of sand is spread across the containment floor area, creating a level bedding surface for the system. Impermeable liner is then placed around the containment perimeter, as well as the transformer pad, using strapping and anchors to properly secure it and hold it in place. Next, smart fabric, or oil mat, is laid out across the bottom of the containment area and secured to the impermeable liner using a specialized sealant adhesive. The excess impermeable liner, both around the transformer pad and the containment perimeter, is now lowered on top of the smart fabric and sealed using the same sealant adhesive. Once this step is completed, the containment is now bonded and ready to accept the remaining layers. Special geotextile SAM, also known as the absorbent layer, is now installed throughout the containment area. SAM is a unique geotextile loaded with a proprietary blend of polymer. It has an exceptional absorption capability per square inch and it serves to extend service life of the containment by protecting the oil mat from small accidental leaks. SAM can be removed and replaced if required. A 2-inch layer of sand, which will act as a cooling and filtration layer, is now placed on top of the SAM geotextile, spread across the containment floor area, and leveled. Non-woven is laid out and will act as a separation layer, followed by the woven geotextile, which is used to move the liquid laterally throughout the containment. The system is filled with fire-quenching stone, which limits and prevents the spread of fire. Finally, the containment is topped and leveled off with substation cover stone to the designated design height. Now let's demonstrate the free draining capability of this system and how it reacts in a typical rainfall event. Unlike the conventional concrete containment, which requires a pumping system to dismiss accumulated water along with an oil-water separator, the SorbWeb Plus system is virtually maintenance-free. The system and its layers are designed to allow water to move freely through its smart barrier without accumulating and pass all the way through the system and back into the native ground. Now watch as this revolutionary multi-layer system of interlocking geotextiles transforms into a rubber seal when exposed to hydrocarbons. In the event of a catastrophic failure, which could lead to an oil spill, the SorbWeb Plus system and its SAM layer absorb the spilled oil, while the oil mat congeals and seals the containment, preventing any oil from passing through.
So if you had a spill, a catastrophic spill, or even, a larger spill, what you would do is you would dig a V channel into the stones in the area where the discoloration can be seen from the leak. And then you would suck up all the free liquid, okay? And then you would keep digging until you reach the bottom layer here, or the oil mat, or you don't see any more oil, whichever one comes first, and you would stop there. Then you would work your way out until you reach the toe of slope on the containment here, or you don't see any more oil, and you would stop there. And then that area would have to be basically cut out, removed, and replaced. Okay. Any questions so far?
Nope.
Perfect. So this is a little video here just to show you an installation that we did for a site. So this is a brand new installation. The transformer is sitting on a pile foundation. Now the customer here wanted to make sure that the containment excavation was kept to a minimum, and it's quite large transformer, so the footprint is a bit on the larger side. So this gives you an idea of how this is installed. So this actual containment took 3 days to complete. Again, not really hampered by weather or temperature. We can install this in pretty much any type of weather. So here they're doing the actual excavation. That might take about a day or two. And then putting in the liners. So that's the impermeable liner on the floor connected to the oil mat on the floor area as well. And then that's the super absorbent membrane. And then they basically finish the rest of the layers and it's basically done. So within 3 days, that containment was installed. So you can see it goes very, very fast. Now we can work with pretty much any contractor to do the installation. It doesn't require any special contractors. We are always going to be on site to oversee that install. So there's always going to be one person from Albury working with the local contractor to make sure that it's installed properly and we can give you a warranty. So as you saw in the previous slides, the containment is very flexible. So if you have infrastructure like conduits, direct buried cables, grounding grid, we can accommodate all of those things either by incorporating them into the containment system or booting and seal around them. Or if you can bury the the cables or conduits or grounding grid below the containment and have them come up the pad. Obviously, that's the preferred method, because if it reduces the amount of intrusions or punctures you put through the containment. But again, you can either have them running below the containment, or again, in the case of a grounding grid, it could come over the pad and lower back down inside the containment here. We're showing here a pad being supported by piles. You can also have a full depth concrete pad and we can strap to it. It doesn't have to be full depth. It could be a shallow pad as well, and we would strap to that. We need a minimum of 8-inch thickness in the pad itself. If the pad is shallow, obviously we have a berm here to prevent undermining of that pad when they're doing the excavation. So that can have some impact on the footprint overall. But again, there's trade-offs in all of these things you have to look at. The berms, as I mentioned, are protected usually by that geogrid, which allows you full access to the equipment drivability. So it's designed to withstand a maintenance truck, or about 24,000 kilograms per tridem axle. So that's, and some of our containment systems with some of our clients are designed for highway traffic as well. So we just need to know that information and we can design the containment accordingly. So these, just to showcase the flexibility, we're not confined to any specific geometric shape. It doesn't have to be a square or rectangle. It can be going around all kinds of different things. So in this case, this is a substation kind of on the side of the mountain. This transformer is over 100 years old, or was at the time, over 100 years old, and quite a lot of oil in it, as well as PCBs. And so that we built almost the entire substation is the containment, and we're using a combination of shallow and deeper areas in order to contain that amount of liquid. The other one is just showing you an above grade option. So in this case, we cannot build a containment below grade for a number of reasons. It's also an existing substation. And so the customer opted for building the containment above grade using above ground composite support wall system. And here we build all the layers and have the water sort of flow through the bottom on a 50 millimeters of pea gravel, and then it just gets discharged onto the surface of the substation. There might be scenarios where we cannot build a containment below grade. For example, if there is a high groundwater, the membrane will allow water to pass through whether it comes from the top or bottom. So it's important that we understand the site conditions and where the water table is. We need to stay away at least 1 meter or 3 feet from the highest level of expected water table to prevent that sort of uplifting and coming into the containment. So those are usually the scenarios under which case you might have to build above grade. This is just showing you that the containment can either be built with the equipment on, or it can be a brand new installation. The equipment can come and be installed later. So this is the below grade system with the earthen berm before the geogrid is placed over the berm to protect that. So once you cover that geogrid with surface stone, you have a nice clean substation that you can just walk or drive over with not really a whole lot of concern. We have thousands of installations throughout North America for many, many different types of customers, whether it's utilities, private sector, renewable energy projects. We work with end users directly to bring these designs to fruition, or their consultants, and sometimes EPC contractors or construction companies. So we're pretty flexible that way. And then, as part of sort of an evolving, as the things are evolving, different types of liquids make their way through, to these transformers. whether it's natural ester, synthetic ester, or diesel, for example. So we did our testing through UL in the United States, and in the process of updating some of the UL standards for above ground storage tanks. And we had our very first installation in the Yukon with two 100,000 liter tanks, and where we installed our containment system, because in those conditions, our system is quite favorable compared to traditional concrete style containments. That pretty much concludes my presentations. If there's any residual questions that you guys have, I'm happy to try and answer them. Yes, go ahead.
So when you put the system in, obviously you're not able to cover the area with one blanketed continuous rolled cloth. How are the seams tied together?
So we're seaming together the mat to mat connections with 1 foot overlap. And we're using a variety of different sealants, from polyurea spray to basically a polyurethane thermoplastic sealant.
Okay, so it's overlapped by a foot on either side, and then it's actually bonded to itself.
Yes.
Okay. What's the anticipated or estimated lifespan of the actual containment fabric?
So if there's no oil exposure, the containment is expected to not degrade. Like, it doesn't, as long as it's covered, there's no expectation for it to biodegrade or in any way decompose. So in theory, it's all plastic. So theoretic life of this is in the hundreds of years. We're pretty comfortable to say that this will last at least 50 years, or the life of the equipment. And
Okay, and then
yeah.
yeah, and then so if there was a potential spill, and the spill is then cleaned up, the fabric's reusable, or it would then have to be replaced based on the initial spill?
It depends on the amount of the spill. If it's a catastrophic failure, the entire containment floor is consumed, and you have to remove and replace it, because once the reaction occurs, it's not reversible. If it's a partial leak, you may not have to do anything about it, or just imagine the floor area of the containment divided up into 4 quadrants. If you have a spill in an area and it's not a catastrophic spill, it's maybe just a major leak, 1 quadrant of the containment is still is affected, but the other 3 are still working. So the containment's still working. So you may want to just repair that 1 quadrant, for example. So that would involve basically removing that section, cutting it, and replacing it with new fabric.
Oh, okay. Excellent. Thank you.
I had a question. So one of the applications we're looking at is 2 transformers next to each other. For those types of setup, I was curious, is it typically just one design for the whole thing, or usually separated?
So really the IEEE guidelines basically call for if you have 2 pieces of equipment that are fairly close together, the chances that both of them will fail at the same time is very small. So you can design one containment around multiple pieces of equipment and account for only the largest oil volume in the one piece that's within that containment area. Now you have to balance that out with a couple things when you have a system like that, like this. If the transformers are spread out too far apart, then there might be an area in between those, okay, where you have basically a large section of mat, which kind of drives up your costs. So you have to, we try to balance that with when we're working with you, to make sure that we give you the most cost-effective design. The other thing you want to think about is, if, for example, if you have 4 or 5 transformers in a single containment, and the containment area is, big, obviously, because it's encompassing 4 pieces of equipment. If one of those were to fail, you potentially would have a larger area that you have to clean up. So, that's something you have to balance, basically cost, and then future state.
Okay.
Anything else?
Just one question there, Carla. In terms of like for the different application, in terms of I suspect that you'd have different math with different oil capacities. Like how is that determined?
So no, the capacity for the mat itself is always the same. So as I mentioned earlier, the actual mats themselves have a negligible capacity when it comes to like the overall containment design. They're there basically to create a barrier and manage sort of chronic leaks. The actual capacity of the containment and the design is going to be determined based on what you want to contain, how much oil is in the actual piece of equipment itself, and then it will determine the footprint. So how big, wide, and how deep the containment has to be in order to contain that total amount of fluid.
Okay, gotcha. Thanks.
All right. Well, if that's all the questions, if anything comes up later, feel free to reach out to myself or Vic, and we are happy to answer anything that comes up later. We can also share with you a link to this presentation so you have it for future reference. If there is something that you're working on now and you want to get an idea of how much something like this would be, our proposals are very thorough. We give you a set of free preliminary designs so you understand how big and what the containment needs to be for whatever it is that you're doing. We also give you a civil materials takeoff list, which tells you exactly how much excavation, how much aggregate, how much labor it's going to take, and how many days it's going to take to do the install. So it makes it very easy for you to determine your installation costs. And we give you a price fixed proposal based on the parameters or the inputs for the design with a full breakdown of everything. So you have a pretty good understanding of kind of what you're getting, and it allows you to plan.
Okay, that's helpful. Thank you very much for
thank you.
Going through this. This is very helpful.
Perfect. Thank you so much for the opportunity. I look forward to working with you possibly in the future.
Thank you.
Thank you.
Take care.
Okay.
Thank you.